So we're going to answer a chemical kinetics tutorial sheet. So this is like the fourth tutorial sheet I'm answering and uploading. So we have quite a number of questions that we're going to go over. So as you can see, question 1, here we're going to determine the average rate of decomposition. Applies to question 2 as well. We have question 3, which deals with reaction orders given the initial rates. And then we're also given the rate of formations for question 4 as well. We'll apply the same concept. So that's still question 4. And then of course we've got a part for the reaction mechanisms. We've got a different kind of a question, but asking us to determine again the lateral. Question 6 is where they've given us the initial rates and then they want us to find x and y. Question 7, they want us to determine the rate of formation in relation to a reactant. And then we have got question 8, got question 9 and 10, question 11, question 12, question 13, 14, 15, 16, 17, 18, 19. So these are the questions that we're going to answer in this video. Okay. So link in the description to the actual full video. Okay, so I'm going to answer a few questions just here. So what is the average rate of decomposition of A to B by the reaction? So one thing that you should know, in my introduction to chemical kinetics, I explained to say that the rate is given by the, if you're talking about the reactants, it's negative 1 over the stoichiometric coefficient. In this case, we're talking about that reactant, so it's a 2 there, so it will be over 2. Change in the concentration, as we are told, change in the concentration divided by the time it took. So that's going to be our formula. So all we just have to do is just substitute the information that has been given to us. So for the change in concentration on top, what do we have? So the final concentration, since we are trying to focus between 600 seconds and 1200, so the final one was 0.93 times 10 to the power negative 2. That was our final. And then minus the initial, which was 1.24 times 10 to the power negative 2. Divided by the change in time, right? So for the change in time, that was from 600 seconds to 1200. So we have 1200 minus 600 seconds. So don't forget that on top we've got concentration, so molar concentration over time, seconds, right? So you can see that the units match up to a rate. So if you're going to subtract what we have on top, grab your calculator, 0.93 times 10 to the power negative 2 minus 1.24 times 10 to the power negative 2, that will give you a negative, divided by a difference there is going to be a 600, and then multiply by negative half. So the answer I'm getting is 2.58 times 10 to the power negative 6 molar per second. So what is the rate? So a rate is change in concentration over the time it took. Of course, don't forget to multiply by the stoichiometric coefficient. So the reason why we add the negative there is to ensure that every time we are determining the rate, it should always be positive. Okay. If we were focusing on the rate of formation of A and B, we could have used a positive instead, because we know that the final, in terms of the products, is higher than the initial. Why is it that for the reactants the final is less than the initial? It's because as the reaction progresses, as we saw from 600 seconds to 1200 seconds, that was a reduction. There was a reduction because reactants react and so they reduce in amounts. Same concept applies to question 2. We want us to determine the rate. Whatever it told us, they've told us we've been given information. What are we told? So that is the equation we are given. Iodide ion is oxidized by hypochlorite ion in basic solution. Okay, the equation has been given there. Okay, and then in 1 molar concentration of sodium hydroxide, the iodide concentration, so the iodide ion concentration was equal to the the hypochlorite ion. Okay, so and then we are told the time. It was from 2 seconds to 8 seconds. They observed a change in the concentration. Okay, so calculate the average rate of reaction of iodide during this time interval. Okay, so what this information is about, what is about iodide ion, as you can see. So if we look at iodide ion in that equation, it's having a stoichiometric coefficient of 1. So in terms of the rate, which is the average rate, of course, because we are looking at it as the range of time, that's going to be -1/1 change in the iodide concentration divided by the change in time as well, just as like we did in the question before. So therefore we have -1. Change in the iodide concentration would be 0.00201 minus 0.00269, and then of course divided by the time the difference, that was 8 minus 2. So for the top part that's smaller, this is seconds. So grab your calculator there. So -1 times 0.00, first of all you can start with what is in the brackets, 0.00201 minus 0.00269. So realize that the other part is bigger, so it is going to be negative, divided by the difference, which is like a 6, and then multiplied by the -1, it becomes a positive result. So I'm getting 1.13 times 10 to the power -4 molar second. Okay, that's it for question 2. You can see that there's actually no difference between question 1 and question 2. They are all based on the same concept. Okay, so we're now on question 3.